Alrighty, everybody. So now in the next couple of videos, I'm going to be talking about areas of regular polygons. I'm going to break these notes into a couple different videos, mainly because there's a lot of information here, and I don't know if we are as familiar with these figures and their area formulas as we were some of the previous ones. So a regular polygon is a polygon with all sides and angles congruent. Okay, so like a regular quadrilateral is going to be a square because in a square, all four sides and all four angles are congruent. So that's how that works. The radius of a polygon, you see we have a couple pictures below it. The radius of a polygon, radius had to do with circles, and that's because the radius of a polygon is the radius of the polygon circumscribed circle, which I know is not a vocab word we're super familiar with or that we've talked about before. Oops, sorry. What that means is if I were to draw a circle, this is not going to be perfect, but I'm going to do my best, that captures the polygon. The radius is going to be the segment from the center to a vertex of the polygon, because if you notice, this segment starts at the center and extends to the edge of the circle. Okay? A central angle is going to be the angle that happens at the center. And the way we find that, and this formula is going to be important, is we take this whole circle that captures it as 360 degrees, and we're going to divide that by the number of side lengths that it has. So 360 divided by n, where n equals the number of sides. Okay? Because what you're doing, if you remember the relationship between the central angle and the arc that it captures, they're equal to each other. So the central angle is going to equal the arc that it captures, and what's happening is that this circle is being divided into the number of arcs that correlate to the number of sides. So there are 5 arcs here that are all congruent. So we take 360 divided by 5 to figure out what the angle of the measure of one of your central angles is. Okay? So that's how you find central angle. That's going to be a big, important vocab word. And the next one, which I don't know if you've heard of before, is called an apothem. And this is also going to be a key vocab segment that we use. So the apothem is the distance from the center to the midpoint of a side. And you see that in the second pentagon there. This is the apothem. So it's the midpoint of a side, so it bisects the side. It's also perpendicular, creating an isosceles triangle with these sides being the radii. Okay? So all these are going to be helpful in finding the area of these regular polygons. Okay? So before that, let's just make sure we're comfortable with these vocab words. We have a hexagon that is captured within a circle. We want to find what is a radius of the polygon over here. Well, you'll notice we have two options. It's got to start at the center, and it has to end up on the circle. So we could say either segment GF or segment GE. Both are valid options. Okay? The apothem starts at the center, and goes to the midpoint of a side. Okay? It's going to be perpendicular to that side. So that's looking at GH. Next, we want to find what is the measure of the central angle. And that's going to be in between two radii. Okay, so in between GE and GF, we're trying to find the measure of that angle. So we're going to take 360, and we're going to divide it by the number of sides. 1, 2, 3, 4, 5, 6. This is a hexagon. Okay, so the measure of the central angle is going to be 60 degrees. Okay, so if I want to find the angle measures in the regular polygon, E to G to F, well, that's what we just found. That's the central angle, so that's 60 degrees. EGH is talking about that right there. E to G to H. So what we want to do with that is take our central angle and cut it in half, because that apothem is bisecting that whole angle at G. So 60 divided by 2, so we're looking at 30 degrees for that. And then the last one is H to E to G, which is talking about this angle right there. So if I look at that, H is my 90, E to G. We just found out that this top angle is going to be 30, which means that this angle right here is going to be 60 degrees, because all the angles of that triangle need to add up to 180. Okay, so that's going to wrap up this first video. I just wanted to go through the vocab. Next video is we will start finding the area of these polygons. We'll figure out what that formula is. Okay.